Hello and welcome to video number 30. We're going to be talking about work and what it exactly is, how it works out. Here we're going to write work as W, and it is very similar to force. However, work also takes into consideration the distance something was being moved. So we're going to call that S. By the way, this work is in units of kilograms per meter squared over second squared, which is also a joule. So the amount of work done of an object depends on how far it is going, and then also how fast it is going, and if there's any resistance to it. For example, however, one thing is, let's say here we have a starting point and an end point. We had an object that goes straight across. That uses the same amount of work as something that goes there, same amount of work exerted, or something that even takes a very long path, but it's because this would count as negative work, positive work, negative work, positive work, negative, negative, positive. So it all actually equals to the same amount as when you go straight up. So now let's take a look how this applies into a problem. So here for number 30, we want to know how much work does it take to accelerate a particle from 10 meters a second to 20 meters a second. How that compares to how much work it takes to accelerate an object from 20 meters a second to 30 meters a second. So for this, we're actually going to use the energy equation here. So we're going to see the total change, which would be equal the mass. Here we're going to have 20 squared, and then all that minus 1/2 the mass times 10 squared. So this would be the difference. This would be the work required to go from 20 to 10. And here we see the amount of work it takes to accelerate a particle from 30 to 20. And if we see here, we actually see that this is actually greater.